welcome back to my channel. I am Rafia Begum, your mathematics teacher. Today we will be doing the exercise 1.3. Before we start the exercise, please subscribe to my channel, press the like button and also press the bell icon to get notified every single time I post. So now let us begin question number 4. Express 0.999 in the form P by Q. Are you surprised by your answer? With your teacher and classmates, discuss why the answer makes sense. So in the previous video, we have already discussed how to express any given decimal in P by Q form. So this is the decimal given, x is equal to 0.999. So in the previous video, we discussed 0.99, how to express it in P by Q form. So if you haven't watched that video, please watch that video, then you will understand more clearly. So now, what is that given decimal can be written as x is equal to 0.999, that called it as equation 1. Now, you can see here children that only one number is repeated here. Only one number is repeated. So one number repeats means you should multiply with 10 both the sides. Okay? So as I already mentioned, x is equal to 0.999, it's equation 1. When we look at this decimal, here 9 is repeating, only one number is repeating. If one number repeats, you have to multiply both sides by 10. So 10 into x, 10 into 0.99. So 10 into x becomes 10x and this becomes 9.999. Call this as equation 2. When you subtract equation 2 minus 1, okay? 10x is equal to 9.99 minus x is equal to 0.99. When you subtract, what you get? 9 minus 9, 9 minus 9, all this becomes 0. 9 minus 0 is 9. 9x is equal to 9 you get. So x is equal to 9 by 9, that is 1. So exactly what you got? X is equal to 1. X is equal to 1. So the value of x is 1. This is how we did with the mathematical way. Generally we can say x is equal to 0.999 is nothing but when we round off it is 1. So in general also we can tell it as 1 and mathematically we can prove x is equal to 1. This is about question number 4. Now let us go to question number 5. Question number 5. What can the maximum number of digits be in the repeating block of digits in the decimal expansion of 1 by 17? Perform the division to check your answer. A fraction in lowest terms with a prime denominator other than 2 and 5 always produces a repeating decimal. This is something mathematically we have a statement that when you have any fraction which is having the lowest terms, then if the denominator is other than 2 and 5, then it produces a repeating decimal. Okay? If x is a denominator, then it generates x minus 1 repeating digits. See here, in our question, 1 by 17 is the question, right? So, 17 is a prime number. It is not having either 2 and 5 as factors here. It is a prime number. So, when you divide this, according to this statement, you will get 17 minus 1, that is 16 digits repeating when you divide. 16 digits repeating. So when I divided, I got 0.0588235294117647. Again, then this pattern will repeat. So according to the statement, I have written 1 by 7 is this much. So if you want to verify, you can do the long division and check. You get this 16 digits repeated always. So this is how we can tell whenever we have any prime number in the denominator. So that number minus 1 number of digits will be repeated. So this is about question number 5. Question number 6. Look at several examples of rational numbers in the form P by Q, where Q not equal to 0, where P and Q are integers with no common factors other than 1 and having terminating decimal representations. Can you guess what property Q must satisfy? So in the previous question we already discussed that whenever any fraction is given, the denominator should be in the form of 2 into 5. Okay. Terminating decimal expansion of P by Q occurs only when the prime factorization of Q have only in the form of 2 power m into 5 power n. That is multiples of 2 and 5 you should have. Then only you can say that fraction is a terminating decimal. So I am giving you 3 examples here. Say for example 7 by 16. 16 is multiple of 2, right? You can write it as 2 power 4. So when you divide this and check, you get a terminating decimal 0.4375. Now you come to another example 24 by 25. 25 is a perfect square, that is 5 square, right? So this is also a multiple of 5. When you divide these two, you get again a terminating decimal, that is 0.96. Sometimes you have denominator with multiples of 2 and 5. Say for example 53 by 100. Directly we can write it as 0.53. It's a terminating decimal. But what is 100? 100 is nothing but 2 to the power 2 into 5 to the power 2. So any denominators having multiples of 2 and 5 will give you a terminating decimal. This is the question where we discussed about these facts. Okay. Now let us come to question number 7. Write 3 numbers whose decimal expansions are non-recurring. So he is asking you to write non-recurring decimal. You can give any example. I have given here 0.460, 4600, 46000. Like that you can go on increasing the number of zeros so that the recurring decimal is not same. Okay. So I have written 3 random numbers 0.321, 32111, 23111, like that. It's a non-recurring decimal. Again 0.02, 0002, 02, 0000, like that you can continue and write any 3 numbers. So this is how you write without any thought. Just like that you can simply write and you will get your non-recurring decimal. Now question number 8. Find 3 different irrational numbers between the rational numbers 5 by 7 and 9 by 11. So what is 5 by 7? First let us divide and see. When we divide and see, we get 0.74285. It's a recurring decimal. Okay. And 9 by 11 is 0.818181 you get. So this is also a recurring decimal. Now you observe here children, this is 71 and this is 81. So you should write the decimals between these two. 71 and 81, imagine, okay, 0.71 and 0.81. So 3 decimal fractions, what I write is 0.720, because after 71 I get 72, 720, 7200, like that, go on changing. After that you can write, I have taken 780, 7800. So similarly 790, 79000, like this 3 decimal numbers I have written. If you want, you can change the number here 73, 74, 78, but it should be between 71 and 81. That your answers may vary. Okay. Now 9th question. Classify the following numbers as rational or irrational. They have given on 5 numbers. We have to classify whether they are rational or irrational. So I just made the box rational and irrational. Now you can see root 25, root 225. Root 225 is a perfect square, that is 15 square. When I take it out from the root, it becomes 15. 15 can be written as 15 by 1. Is it of the p by q form? So that is the rational number. Okay. Then 0.3796, it's a terminating decimal. Terminating decimal is always a rational number. Okay. Then 7.478, 478 is recurring here. 478 is recurring, same number repeats, means that is also a rational number. So these 3 numbers come in rational number category. And root 23 is a surd. So this is an irrational number which is non-recurring. Okay. Then 1.1010010001. So this is also non-terminating and non-recurring. Therefore this is also an irrational number. So okay, with this we end the exercise 1.3 and I hope you understood everything. So don't forget to share, like and subscribe. Thank you very much children.